Hey, this is Wojo, and today we're going to be looking at adding and subtracting polynomials. The nice thing about adding and subtracting polynomials is most of you already know how to do this, whether or not you realize you do or not. You've been adding since you were probably 5, 6 years old. And this idea of adding polynomials is no different than when you were adding things when you were 5 or 6 or 7. One of the things that's most important when you talk about adding polynomials is that we only add like terms. And sometimes that idea of like terms gets confusing. And so what I'll talk about is you guys have been doing adding like terms for, like I said, since you were 5 years old. So if I asked you what's 4 apples plus 2 oranges plus 3 apples, you guys would all say, well, that would be 7 apples and 2 oranges. You would never add the 4 apples to the 2 oranges because these aren't the same type of things. These are not alike. The things that are alike are the 4 apples and the 3 apples. So you would say altogether I have 7 apples and I have 2 oranges. You can't add the 2 to the 7 because they're different things. And that's the way you want to look at adding polynomials. When you go to add something like this quadratic trinomial and this quadratic trinomial, you have to look, is there anything that's alike? And so really what we'll be looking at today is how do I read what I'm looking at? Because that's really where students struggle, is they're not 100% sure what they're reading. When you read this, this reads you have 4 of these x squared. So kind of imagine you have these x squareds hanging out, and you have 4 of them. Well, if you said, well, if I had 4 of these x squareds, I couldn't take away 7 x's from them because there's no x's here. These are just x squareds. And so what you would do is you would look for the other like terms. In this case, the other like terms are these here. These 3x squareds are just 3 more of these little x squareds hanging out. So if I said, all right, let's simplify, let's put them all together, how many x squareds do we have total if we had 4 of them here, and then we had 3 of them here? Well, 4 plus 3 is 7. So when we simplified it, there would be a total of 7x squareds. If I keep going then, I would look at the next things I have. And again, most of it's about reading. So when you go to read this, it's about reading what you have here. When I read this, I have negative 7x's. So the sign in front tells you a lot. The sign in front tells you how many of them you have. Here, this was positive, and in this one, it's negative. So I have negative 7x's. So I'm already in the hole 7x's. But then I'm going to add to it 5x's. So if I look at these terms here, if I'm at negative 7 of these x's, and then I add 5 to it, I'm still in the negative, but I'm only in the negative by 2. So negative 7 plus 5 is negative 2. What do I have negative 2 of? I have negative 2 of the x's. And so that would be the next part of this. And then you would simply finish it off by looking at the last terms, which is the 5. All right, I have 5. It doesn't say 5 of what, just 5. But then at the end, I'm going to take away 8 from it. Again, the sign in front makes a difference. So this 8 is negative. This 5 is positive. So I've had positive 5. I had $5, let's say. But then I lose 8. 5 minus 8 is negative 3. Now when you write your answers, you always want to write them from highest power. So x squared is the highest, x to the first, and then x to the 0 or no x's. This is called standard form with the highest power first, and this is last. And that's all there really is to adding. You just put the like things together. The 4 and the 3 make the 7. Boom, boom, boom. Sometimes people get confused of, well, why are these in parentheses? And in this case, we kind of ignored the parentheses, and sometimes we can and sometimes we can't, and that's part of the kind of understanding of what we're looking at when we're reading these. So let's look at an example where we can't ignore the parentheses. So let's look at another example. So the directions of all of these are going to say simplify. But let's look at one where you can't ignore the parentheses. So what if I said 4x squared minus 7x plus 5. So I'll use that same one. But this time I'm going to subtract the 3x squared plus 5x minus 8. So the only thing I changed in this problem is in the top problem I was adding these. In the bottom one I'm subtracting them. Now when I'm adding this whole thing, basically what I did and why I could ignore it is because this plus sign gets kind of distributed to all of them. And when you multiply by a positive, if you want to think it was a positive 1, it doesn't change any signs. But when you see this negative sign out front, we talk about, well, who does this negative sign belong to if a parentheses in a group follows it? Well, what's in front is where the sign goes. What's in front counts. So this negative sign belongs to all of this. Because there's all this parentheses, this negative sign belongs to all three of these. So our very first step really is to kind of distribute this negative sign and give it to all three pieces. So this was a positive 3x squared. When I give a negative to a negative times a positive is a negative. So that 3x squared becomes a negative. Again, this negative also goes to this 5x. So what's a negative times a positive? Again, if I want to distribute it out, again, you can kind of think of it as a negative 1 if you want. A negative times a positive is also a negative, so that becomes a negative. But then when I go to give it to the 8, a negative times a negative makes it a positive. And so after I change these signs, after I give it to everything, I can pretty much just make this a plus again. I can just say, well, I'm adding all of those things. And so one of the first things we do when we have a subtraction problem is we give or distribute the negative to everything inside. Here we just distribute the positive. What's a positive times a positive? It's still positive, so it stayed. Positive times a positive, still positive, so we didn't touch it. A positive times a negative is a negative, so it just stayed. So we didn't have to actually distribute anything. But when there's a minus sign out front, you have to do that extra work. After that, the nice thing is, adding, subtracting are still the same. The apples go with the apples, the oranges go with the oranges, and so forth. So we have a 4x squared. Well, who are we going to combine that with? Well, not an x. X squareds are different than x's. They don't look the same. So I have 4x squareds, and then I look over here and I have a minus 3x squared. So if I had 4x squareds, so this is how I think of it. Here's my 4x squareds, and then I'm taking away 3 of them. So there goes 1, there goes 2, there goes 3. What's left? I just have 1x squared left. So 4 minus 3 is 1. You could write 1x squared or just x squared. And then just keep going down the line. Next we have the negative 7x. Well, who does that combine with? Who's its like term? That would be the negative 5x. So now I have negative 7x's, and I take away 5 more. I'm already in the negative 7. I take away 5 more. Now I'm in the negative by 12. So I have negative 12x. And then finally, I have my 5 plus 8. 5 plus 8 is 13. And so our answer in standard form, when I subtracted those polynomials, would be this. And so again, the biggest thing is, when there's a negative out front, you got to distribute to everything. Only if it's out front of a group of parentheses. All right, and then finally, just one more example just to make sure. Sometimes you'll look at problems where there'll be x's and y's. And so if we had something like 5x squared y plus 3xy squared plus 8x squared y minus 2xy squared. Again, you look for the things that are alike. And so the like terms on this one, well, what do we have 5 of in this case? We have 5x squared y's. Where else do we have x squared y's? Well, this is not an x squared y. This is an xy squared. Here's an x squared y. So how many do we have total of these x squared y's? 5 plus 8 is a total of 13. 13 what? X squared y's. What else do we have in this one? We have 3. 3 of what? Xy squareds. If I have 3xy squareds minus 2 more xy squareds, 3 minus 2 is just 1. Positive 1xy squared. And again, you didn't have to write that 1, but you can. So we look at adding, subtracting polynomials. Just make sure that you are adding, subtracting like terms only.